Hello students, welcome to Educate. In the previous classes, we have discussed about the various theories regarding the atomic model. Now, during that course, I have left few in-text questions and the few concepts. About that we will discuss, and then after this video, in the next video, we will discuss about the quantum mechanical model of atom. In atomic theory, in atomic model, the last model which is accepted till now is quantum mechanical model. About that we will discuss then after solving the in-text questions of this chapter and the other theories which will require to study about the quantum mechanical model of atom. So let's see, first of all, let's see here about this question. Rutherford atomic model we have discussed already. Now let's see atomic number and mass number. I think all of you have studied in class 11th or the class 12th. Atomic number means here already given here number of proton in the nucleus of an atom, and in a neutral atom number of electron, that is equal to number of electron also. So mainly here an atomic number is actually the number of proton in the nucleus and number of proton in the nucleus and in a neutral atom. Since in a neutral atom number of proton equal to number of electron, that's why in the neutral atom the atomic number will be equal to the number of protons, and that will be also equal to the number of electron. And based on this one, that is actually what is the atomic number. And mass number is what? Mass, atoms have negligible mass, 9.1 into 10 power minus 31 kg. So that is very less. So electron has negligible mass. So for the mass, the responsible is atomic, that is the responsible for the mass is the proton and the neutron. So mass number will be equal to the number of proton plus number of neutron. So atomic number equal to actually atomic number is number of proton and mass number, that is equal to number of proton plus number of neutron, that is mass number. Then after about the isotopes and isobar, what is that? This one, what is isotope and isobar? Isotope, iso means same. So isotope means the number of proton will be, that is not, the atomic number will be same but mass number will be different. So isotopes are the elements which possesses same atomic number but different mass number, that is isotopes. Not written, okay, listen here. So isotope means isotope means same atomic number but different mass number. Like that, in case of hydrogen exists in three isotropic form, that is protium, deuterium and tritium. Hydrogen exists in three isotopic form, that is protium, deuterium and tritium. So protium H1 we take consider because its abundance is maximum, 99.99% is protium. So that's why we hydrogen which we represent, that's actually we represent the protium. Deuterium, yes, its abundance is 0.015%, and tritium about that is 1 in 10,000. So that is tritium here, and tritium is radioactive. So protium, deuterium and tritium, they are the example of isotopes. That means hydrogen exists in three isotropic form, that is protium, deuterium and tritium. In the same way about the chlorine, here average atomic mass was 35.5. So if number of proton plus number of neutron can never be in fraction, but atomic mass you have to watch out, that is 35.5. So what is here actually? So chlorine exists in two isotopic form. Chlorine exists in two isotopic form, that is chlorine 35 and chlorine 37. Okay, so like hydrogen exists in three isotopic form, that is protium, deuterium and tritium. So in the same way, one example is that. Second example is chlorine. Chlorine exists in that is chlorine 35 and chlorine 37. That is okay. So that was about the isotopes. In the same way, there is isobar. What's in the isotope? In the isotope, there is that exist in that have same atomic number but different mass number. And in the same way, isobar that will have same isobar that have same mass number but different atomic number. Isobar. Isobar means two elements having sorry. Isobar is the element having same mass number but different atomic number. As for example, carbon 14, which is radioactive, and nitrogen 14. They are isobars. Okay. Isobars means that have same mass number but One point here I have written that isotopes possess same atomic number while the isobars possess different atomic different position in the periodic table, which is obvious. May you think here no need to mug up also this point. Why this one? Because the modern form of the periodic table is based on the atomic number. So in case of isotopes, their atomic number is same. Okay, so despite of having the different mass number, they occupy the same position in the periodic table because their atomic number are same. Okay, that is. Now let's see. Now watch out these questions. With this question, firstly read, then after I tell you how to solve this question. Now watch out this question. You have to find out number of proton, neutron and electron in bromine 35. So what's written in the okay. This is the question. So what's here? 35 it is in subscript and 80 is in the superscript. So which is written in the subscript, that is actually atomic number. Which is written in subscript, that is atomic number. And atomic number is equal to the number of proton, and here on the bromine there is no charge, no positive charge, no negative charge. So this is a neutral atom. So in a neutral atom, the number of proton equal to number of electron. So since there is number of proton equal to number of electron and number of proton is 35, so number of electron will be also 35. So let's see here. So number of proton will be how much? So number of proton here, that will be equal to 35, and this is a neutral atom, bromine 35. It is neutral. So since it's a neutral means here no positive charge and no negative charge. Since there is no positive charge and no negative charge, so that is it's a neutral atom, and therefore number of electron equal to also 35. In the superscript represent the mass number, and for the mass number there will be number of proton and the number of neutron. So you know, so 80 will be equal to, this is mass number, because you know mass number equal to, since mass number equal to mass number, that is equal to number of proton plus number of neutron. So mass number is 80, so 80 that will equal to number of proton is given 35, so that is 35 plus number of neutron. So number of neutron will be equal to 80 minus 35, that is 45. So there is atomic number of proton is 35, but number of neutron is 45. Okay guys, so that is here. Listen here. Watch out this question. So this in this question there is number of electrons, protons and neutrons are given, and that are 18. That means the number of electron is 18, number of proton is 16, and the number of neutron is also 16. So assign the proper symbol to the species. What will be the proper symbol. So let's see here proper symbol how to predict. So since atomic number is equal to the number of proton and number of proton, this is number of electron is 18 given already and number of proton is 16. So atomic number, suppose that element is X. So atomic number is equal to number of proton and the number of proton here is 16. So that's why here 16. And number of electron is 18. That means number of electron is 2 more than the number of proton. Since number of proton is 16 and the number of electron is 18. So number of proton is here, number of proton is 2 less than that of electron. So here number of electron is more. That means negative charge is more. And how much more? By 2 unit. So 2 unit. So that's why 2 unit negative charge will appear here. And number of proton, number of neutron here also is 16. So mass number will be equal to mass number that will equal to 16 plus 16, that is 32. So on the superscript we write 32. And here atomic number 16 is for sulfur. So that means this element is sulfur. This element is actually sulfur, whose atomic number is 16 and mass number is 32, and there is 2 unit negative charge. So this species is actually disulfide. Guys, a number of students faces difficulty that where sometimes there is written "ide," sometimes written "it," and sometimes written "it." How? So they faces difficulty. So what to write the name of the compound? Guys, I am telling you here what happened here. "Ide." When the negative charge will be on the non-metal atom directly, like here sulfur, on the sulfur there is 2 unit negative charge, so you told sulfide, IDE, ide. In the same way, if there will be oxygen here and oxygen has 2 unit negative charge, and how to predict the negative charge? So oxygen here, octet, that means atomic number is 8. So electronic configuration will be 2 and 6. So to acquire the octet, it needs 2 electrons. So that's why if 2 negative charge will be there, then we write "ide" in the name of oxygen. So that's why it is actually here, this is oxygen. So that's why we write here the suffix "ide." So this will be called oxide. In the same way, there will be nitrogen. Nitrogen atomic number is 7. So 2 and 5 will be the electronic configuration. And so to acquire the octet, so nitrogen needs 3 electrons. So if there will be 3 negative charge on the nitrogen, then in the nitrogen we will use the suffix "ide." That's why it is called nitride. In the same way, if there be chlorine atomic number is 17. So electronic configuration 2, 8 and 7. You already know about the electronic configuration. In the 10th class you have studied this one in detail. So electronic configuration is 2, 8 and 7. So to acquire the octet, the oxygen or the chlorine needs 1 electron. So that's why if there be 1 negative charge on the chlorine here, then simply we will tell chloride. Okay, anything more? Like in the same way, if there will be bromine, then bromide. Phosphorus, so phosphide. So the word "ide" we use when the sulfur, there will be negative charge on the non-metal atom directly, like this one. Another one is "ite," ITE, ite. What's the difference in the "ide" and "ite"? So when there will be oxygen and the if when there will be oxygen combined to that non-metal, and in that case the that non-metal acquire the 2 unit less oxidation state than that of the maximum oxidation state shown by the elements of that group, then the word it will be used, like SO3 2 minus. Okay, this one I hope clear. So now I am telling about the also to how to write it, when to write it. Like SO3 2 minus here. The maximum sulfur belongs to which group? Group 16. Okay, maybe you feel difficulty here if you have no any idea of the oxidation state. So who have not studied about the oxidation state or redox reaction of this chapter may skip out this topic, because this is I am telling only the technique. So okay, I am telling here. So sulfur here belongs to group 17. So maximum oxidation state exhibited by sulfur will be 17 minus 10, that is 7. Sorry, group 16. The sulfur belongs to group 16 elements. So maximum oxidation state shown by the sulfur will be plus 6. Here sulfur is in plus 4 oxidation state. How's X plus, there is 3 oxygen and oxidation number of oxygen is minus 2. That equal to minus 2. So X equal to plus 4. Here oxygen is exhibiting the plus 4 oxidation state. That means sulfur is exhibiting the 2 unit less than the oxidation state. 2 unit less than the oxidation state exhibited by the sulfur. That is maximum of oxidation state is 6. And here the sulfur is exhibiting the oxidation state of plus 4. The maximum oxidation state shown by the sulfur will be plus 6, because the sulfur belongs from group 16 elements. So plus 6, and sulfur is exhibiting the oxidation state of plus 4. That means sulfur is exhibiting the oxidation state 2 unit less than the maximum oxidation state could be shown by the sulfur. So that's why we use a word sulfite. So it will be it. In the same way, PO3 2 minus. Okay, so in PO3 2 minus, phosphorus belongs to group 15 elements. Phosphorus phosphorus belongs to group 15 elements. So group 15 elements, so maximum oxidation state phosphorus could show is plus 5. Here what's the oxidation state of phosphorus? That is X plus 3 into minus 2, that equal to minus 2. Okay, about that we will discuss later on also. So not right now. Maybe you also feel confusion here. So it what is that? That was about the drawbacks of Rutherford's model. About that we have already discussed. Now proceeds to the next question. That is here developments leading to the Bohr's model of atom. So one is that is wave nature of electromagnetic radiation. First is what is wave? Wave is actually disturbance. Wave, that means everything is the stationary state. Wave means there will be disturbance. Like that, in a pond, so suppose the surface, when you are watching the surface, So it is like this one. Surface, so like this one. Just the calm, if the pond is calm, when the pond is calm means there is no waves, no disturbance in that. If anyone will throw a stone on this one, then what happen? This particle will go above and come below also. That means this particle will oscillate. There will be a maximum point to which this particle could go. So that maximum point where till where the particle can go, that is the maximum point till where the particles can go. That will be called amplitude of the wave. Like that, in a string there, this is a string here. When you jerk this one, so what happened? Particle, this particle go above and below, and same to the near particle also, that will go above and below. This particle will go above and below, same this particle will go above and below. So in this way, wave will propagate from this point to this point to this point. Wave will oscillate from this point to this point, and the particles, these particles will oscillate above and below, perpendicular to this point. So that will be called this wave, that is called, so maximum point to which these particles can go above and below, that is called amplitude of the wave. Amplitude of the wave means the maximum point to which the particles can go, that will be called amplitude. So just a moment. So this will be called amplitude. Okay, amplitude is that maximum point to which this wave can go above and below, that is called amplitude. And the wave will propagate in this direction, so it is direction of propagation of wave. And this is here, this point will be called amplitude. Amplitude, that is maximum point to which the waves can go. Okay, in the same way, this particle can go to that point and to this point. So it is amplitude. This is also amplitude. This is also amplitude. Okay, don't consider that. So when we plot, just keep in the mind, this particle here when go, so we are when plotting a graph, when we plot the graph of position versus time, when we plot the graph of a particular particle, the graph of the position of a particular point, particular particle with respect to time. So it is position of particle. Position of particle. And here time. What happened? Just watch out here. Particle at t equal to 1, particle is at here. T equal to 2, particle is at here. T equal to 3, particle is here, at here. T equal to 4, particle is still here. Suppose amplitude is here. So 1, 2, 3, 4. This one is the fourth. That 4 is the maximum point. Then after particle will again come here, will come here, will come here, will come here, will come here, and like that. So in this way, that means when you plot the graph, so graph will be like this. Particle is not oscillating like this. Just again watch out. Just again watch out here. When you oscillate, particle of here, don't come here. Particle is not coming going from here to here. Here particle is oscillating above and below. This particle is oscillating above and below. So what you see, that is actually you are watching the position of a particle with respect to time. So when it comes here like this one, again when time goes, so again like this particle, firstly go like this particle here. About this particle, I am taking here. So this particle go here, 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 till goes at the maximum position. Then after again that comes, that again come to the original position, and here original position and go below to that original position also. And there it reaches at the maximum point, and then after it's again come towards the positive x-axis. That is here, this is the x-axis here, and so particle is oscillating in y-axis. So it goes towards the positive y-axis, and then after again come downward. Okay, so that is actually the wave which we represent. That is actually the position of particle. That is actually the graph of the position of particle with respect to time. Okay, so don't consider about that, because a number of students thinks that particle is oscillating like this. No guys, that is your misconception. That is the misconception of a number of students. Actually that is not. That is actually the position of particles with respect to time. The particle firstly go towards the positive y-axis. Again time proceeds, so again that particle return towards the origin. But at the origin, particle don't stop. That go towards the negative y-axis and reach there at the maximum, and then after again that particle moves towards the origin. And so and when it reaches at the origin, again that particle move towards the positive y-axis. So particle here is going at the maximum point, then after comes below, again come at the maximum point of this one, again comes towards the positive y-axis, and like that. So that is the position of a particle with respect to time. Okay, amplitude is maximum position to which the particle can go. That may be above or that may be below also. Okay, now the distance between this point, that is called crest. This one is the maximum point. Maximum point, that is called crest, and the distance from the maximum point, that is called amplitude. Okay guys, keep in the mind, don't be confused. What's the difference in crest and the amplitude? Amplitude is the distance between the crest and the origin, that is amplitude, and crest is the maximum point, the maximum distance from the origin, the maximum distance of the particle from the origin, that is crest. So this is crest, and distance from the origin, that is called amplitude. Same here, this minimum point, that is here, this maximum distance of the particle from the origin in the negative y-axis, that is called trough. And same distance between this trough and the origin, the distance between this trough and the origin, that is called amplitude. This is also, this distance is called amplitude. This distance is called amplitude. Okay, another graph I have to draw. Like this is the wave. Distance between this two crest or between this two trough. The distance between two crest and the two trough, like this one. This is called wavelength. The distance between the two crest and the true trough, that is called wavelength. Okay, what is the wavelength? What is crest, what is trough? Frequency is what? Like this particle here, in 1 second, how much times this particle can go above and below? That is called their frequency. Frequency, like that here, suppose this wave also. So from here, particle go maximum point. So it is maximum distance is amplitude here, because after that it's not going. So this is amplitude. Again come to the origin, go above, and then after return to the original path. So that is called frequency. Frequency here, come here, and now this one, this time. That is called frequency. So frequency is in 1 second, how much, that means number of oscillations in 1 second. That is called frequency. Frequency is number of oscillation. Per unit time. Okay, the unit of frequency indicated by nu. So unit of frequency, SI unit. So SI unit of frequency is second inverse, or that is also called hertz. SI unit of frequency is second inverse, or that is also called hertz. Okay, and for any wave, velocity will be equal to their wavelength into frequency. Velocity of any wave, that will be equal to wavelength of that wave into their frequency. That is called wave. That is the relationship between the velocity, that is the speed of that wave, wavelength, and the frequency of that wave. Okay. Okay, then after is light. What about the light? Light is an electromagnetic radiation, or that is an electromagnetic waves. Light is electromagnetic waves. Okay, so might be before this class, before the 11th class, might be you don't know that what is the meaning of actually electromagnetic wave. And maybe who is in the class 12th or preparing for the entrance examination, might be they also not know what is the meaning of electromagnetic waves. Okay, what the actually meaning? Yes, a number of students don't know about what is the meaning of electromagnetic waves. So listen here, that will not ask in examination, but that will prove as a pivotal concept for you, the meaning of electromagnetic waves. What is that here? When electric field oscillates, any charge object here is, if there will be more charge like this, so electric field will oscillate. Perpendicular to that, magnetic field also oscillates. When electric field and the magnetic field oscillates perpendicular to each other, then perpendicular to both of them, that is perpendicular to the electric field and the perpendicular to the direction of oscillation of electric field and of the magnetic field, a wave originates, and that waves is called electromagnetic waves. When the electric field and the magnetic field, both oscillates perpendicular to each other, when electric field and magnetic field oscillates perpendicular to each other, then perpendicular to both of them, that is the direction of oscillation of electric field and the magnetic field, a new waves originate, that is called electromagnetic wave. Like this one here, suppose electric field is oscillating in this direction. Electric field oscillates in this direction. Magnetic field oscillates in this direction. So this direction and this direction is perpendicular to each other. So perpendicular to this one and this one is this one or this one. So when electric field oscillates in this direction, the magnetic field oscillates in this direction, then electromagnetic wave from here, the electromagnetic field will originate in this direction or in this direction. So that is electromagnetic waves. So when electric field oscillates in this direction, magnetic field oscillates in this direction, then perpendicular to this and this, that is this one or this one, the waves originate, and that wave is called electromagnetic wave. Example is light wave. Light wave is a type of electromagnetic wave because the light waves originate by the oscillation of electric field and the magnetic field perpendicular to each other. Okay, so first of all is what is electromagnetic wave or electromagnetic radiation. Radiation means that is which waves originate, that is called electromagnetic radiation. Okay, let's see about this one. Here in the figure, maybe you feel difficulty. This one here, this line represent the electric field component. That means and this is x-axis. This is which y-axis, and this is z-axis, the magnetic field oscillate. Okay. Watch out here. This one electric field oscillates in y-axis. Suppose this one is x-axis, this is y-axis, and this is z-axis. X-axis, y-axis, and z-axis. So what happened here in the y-axis, like this axis? Suppose electric field originates here. Electric field oscillates in this direction. Magnetic field oscillates in this direction. So in x-axis, a waves will originate, that wave will be called electromagnetic wave. As I have told you, same concepts has been taught here. Same concept is here. That is here. Watch out. This one is y-axis. So this green line, this one, this represent the magnetic field component. That means the y-axis. That means if magnetic field oscillates in this direction, there is a wave of magnetic field in y-axis, and in the z-axis there is a wave of magnetic field. So in the x-axis the electromagnetic wave will originate. That has been shown here. Okay, one point you may already know, to propagate the electromagnetic wave, there will be no requirement of, here is, unlike sound waves or waves produced in water, electromagnetic waves do not require medium and can move in vacuum. You already know electromagnetic waves can travel in vacuum also. So electromagnetic spectrum, that is here, you already know white light, that is visible light, that is made up of different types of waves. That is 7, that is constituted of 7 colors, you know already. So that is here written. So electromagnetic spectrum, that is when passes through the prism, when the white light passes through the prism, then a spectrum obtained. So that is visible light. What is that? The speed of light is always constant. The speed, what point also keep in the mind, whatever be the source of originating of light, whatever be the source of light, the velocity of light will be always constant. That is 3 into 10 power 8 meter per second. So that is here. That was about the sub few points about which you must know. That is here. How that is originating, that is already clear here. Sound waves, this one. Now let's see to solve this question. Wave number is the number of waves per meter. That means in unit distance, how much there will be waves. That will be called wave number, and that is represented by nu bar. Wave number is, that is nu bar. Wave number, that's the nu bar, that is equal to 1 by lambda. So there is here in this question, these two questions, let's see. It's a broadcast on a frequency is this much kilohertz. Kilohertz means 1368, so that means 1368 into 10 power 3. That is the frequency of that wave. So in Vivid Bharati stations, in All India Radio, the frequency of that wave is this much. You will have to find out wavelength of the electromagnetic radiation emitted by this one. And what's the, here it is, in which range it is coming. So frequency here this much. So wave, you already know, that is electromagnetic wave. So velocity is equal to nu lambda, you already know, that is given here. So frequency, velocity of light 3 to 10 power 8 meter per second, that will be equal to 1368 into 10 power 3 into lambda, this much. So frequency, so lambda will be equal to 3 into 10 power 8 meter per second. It is in hertz. Hertz means second inverse. That upon 1368 second inverse. So second inverse cancel out. So what will be there? After solving this one, it will come 219.3. So 219.3 meter. So that will be the wavelength. Not very easy question. Huh? Now let's see second question. Violet to red. Okay, and that is wavelength is too much high. So wavelength is too much high. So that is will be the characteristic of radio waves. Now violet wavelength is this much and red is this much. So express these wavelengths in frequencies. So you find out the maximum wavelength will be how much, and then after minimum wavelength will be how much. So frequency greater, so wavelength will be greater, smaller, then wavelength will be larger, and frequency will be larger, then wavelength will be small. So first one here is a maximum wavelength will be how much? Maximum wavelength, that will equal to, so you already know C equal to nu lambda. So lambda will equal to C upon nu. So that will be 3 into 10 power 8 meter per second. That upon frequency is okay. Wavelength is given. So nu also you can find out. C is equal to given. You already know C equal to nu lambda. So nu will be equal to C upon lambda. So maximum frequency will be how much? Maximum frequency. So that will equal to 3 into 10 power 8 meter per second. That upon 400 into 10 power minus 9 meter, nanometer. 1 nanometer is 10 power minus 9 meter. So after calculation, how much you will get? You will get 7.5 into 10 power 14. So 7 meter cancel out. So that will be second inverse. So that will be 3 to 10 power 8 divided by 400. That will be 7.50 into 10 power 14. That will be second inverse, or that is also called hertz. Second inverse is also hertz, called hertz. So that will be, so maximum frequency will be that much. Now minimum frequency will be how much? So minimum frequency will be, minimum frequency, that will be equal to how much? So that will be same 3 into 10 power 8 meter per second. That upon ever is 750 into 10 power minus 9. That much meter. Whatever you calculate. Okay. Now let's see about this question. Wave number, frequency radiation having wavelength, this one. 5800 angstrom is the wavelength. So wavelength is 5800 angstrom. That means 5800 into 10 power minus 10 meter. That is, so wave number, that will equal to 1 upon lambda. So 1 upon 5800 into 10 power minus 10. That is meter here. So whatever be the calculation, you find out that is wave number will be that much. Then frequency. So frequency you will have to find out. So C upon lambda, that will be equal to 3 into 10 power 8 meter per second. That upon 5800 into 10 power minus 10. That meter. So that will be in the second. So in this way, you can solve this question very easily. Okay. So in the next class, we will discuss about particle nature of electromagnetic radiation. That is about the Planck's constant theory. We will discuss in the next class. Okay. It's all for this class. Thank you. Team Educate.